This is called as redundancy theorem in Boolean algebra. X ORed with Y is same as X ORed with X bar Y. Okay. Similarly, we are going to look at few more important relationships. So I am going to write X, Y. So again, two inputs. So what are how many possible input combinations? 4 possible input combinations. Okay. Now I am going to OR them, X or Y. What will be the outputs? Tell me quickly. Just now we discussed. 0 ORed with 0 gives me 0, 0 ORed with 1, 1 ORed with 0, 1 ORed with 1. Now what I am going to do is, I am going to do X plus Y the whole bar. I am going to, please note, I am inverting the OR of X and Y. So OR of X and Y is 0, this one. I am inverting this. So it will give me 1, 0, 0, 0. So let me invert X alone. Let me invert Y alone. What will I get? X is 0, so X bar will be 1. X is 1, so X bar will be 0. Y is 0, Y bar will be 1. Y is 1, Y bar will be 0. Y is 0, Y bar will be 1. Y is 1, Y bar will be 0. Now what I am going to do is, I am going to do X bar ANDed with Y bar. That is, I am taking the AND between these two. What will I get? 1 ANDed with 1 will give me 1. 1 ANDed with 0 gives me 0. 0 ANDed with 1 gives me 0. 0 ANDed with 0 gives me 0. Correct? Now look at this. This column and this column of truth table are exactly the same for these input combinations. So based on this, I am going to write X plus Y the whole bar is X bar dot Y bar. Similarly, I am going to take values here. So 0, 0, 0, 1, 1, 0, 1, 1. Now I am going to do AND of X and Y. So clearly 0 ANDed with 0, 0 ANDed with 1, 1 ANDed with 0. All these things gives me 0. 1 ANDed with 1 gives me 1. Now I am going to invert this. The output of this AND operation I am inverting. I will get, wherever this is 0 I will get 1, wherever this is 1 I will get 0. I am going to compute X bar and Y bar. So I will get this. Now I am going to add X bar and Y bar. So what will I get? Or both of them. I am going to OR X bar and Y bar. 1 ORed with 1 gives me 1. 1 ORed with 0 gives me 1. 0 ORed with 1 gives me 1. 0 ORed with 0 gives me 0. Again, look at this. These two columns of the truth table give the same output for these input combination. Correct? Correct? For this input, that is for every possible input combination, this and this are giving the same output. It is not that for few input combination their outputs are matched, for few input combination their outputs are not matched. Not that way. For every possible input combination their outputs are matched. So I can say X dot Y the whole bar is x bar plus y bar. These two put together are called the De Morgan theorems or De Morgan laws or De Morgan theorems.